and we start with the first episode of 2026 with a nice new agenda and a lot of points that you already know. Of course, it's about green blue because that's the cafe green blue that we do every week 4:30, and this is the start. And I do that together with Charney and Sydney. You want to share some words? The first episodes, Sydney. That's a tradition, right?
I'm really happy that we're starting again this year with the new cafes. We updated our site a bit. We still have a bit of an agenda to fill, but we're very happy to have a topic for today and next week. Really interesting. I think we're diving a bit more into the academic side, but probably that will change over the year. We usually do all kind of projects, from small student projects about green blue infrastructure, PhD students, we had them the last year, but also project leaders, participation programs, and it varies, like I said, from green infrastructure to solar panels, roads, floating cities. And now we got another topic again. So it's going to be another great year.
Nice.
Sure.
Yeah. And you as well, Charney, looking forward to it this season.
Yeah, there's a lot of interesting topics I think that we'll be discussing this year. So looking forward to that. There's already quite a few people lined up and some really nice research going on. So excited to hear all about that.
Perfect. Yeah. And we're going to start off now with basically a topic of the perfect sponge. Yuri, who's also in the call, had an episode about that. Of course, we looking for sponge cities, an answer to drought, an answer to floodings, but also green. And we have Ginta today, all the way from Latvia. And she's ready to share a presentation about digital twins. And you also have some questions for us. So we're excited. I think I will just give you the floor, Ginta, to share some words about yourself and the topic and what you're going to present.
Yeah, okay, thank you. Probably I will start with sharing my screen while still the communication is good. I think it will stay. And before a few minutes ago, I had one meeting. Suddenly it was interrupted, but I think everything will go smoothly now. Hello everybody once again. My name is Ginta Majore, and today I'm presenting Riga Technical University. I'm field expert for building digital twins, as I was invited in this project. By the way, interesting thing is that from my background, I'm computer scientist. And just probably accidentally, or not that accidentally, I entered this field because I was passionate about simulation modeling for the environment and how technologies can help in this process, and how we can build really technological solutions that works for environmental modeling. I started this evaluation or research about ecosystems already, I don't know, more than 10 years ago. But the interesting thing is that initially my PhD thesis was about IT ecosystem for continuing education. And what I tried to do in that topic, I tried to discover this ecosystem principles and incorporate them into computer science systems. And I was so passionate about ecosystems that I don't know how it happened, but after a while, I was suddenly appeared in the field of ecosystem modeling. Of course, I'm still learning in that process a lot, because that is my very interest. And today I will explain probably, or I will tell my experience about digital twin development from technological point of view, not so many from really simulation outcome or results. But I am happy to discuss and to share my knowledge and I really appreciate your feedback about some particular objects or research questions what I'm thinking about. Initially, also in the agenda, I included what we know or what we have digital twin by definition, and here are also challenges when we are really start to think about digital twins in terms of technological point of view. And I will explain my experience from rural areas, from agriculture, and from now this urban areas, how far we are, and our plans in the future. Digital twin by definition is here in this third part we can see. So first of all, what we have from originally we have the digital model, which actually takes data from the physical entity and process them and represent in some kind of chart or graphical representation. Typical example is crop grow, or also this, for example, evapotranspiration, this data, what we can show in the model. Second, when we take this data online, for example, from physical entities, and it could be sensor data from soil moisture, sensor data online processed from, for example, drones, or from satellite data. We process them, but still we show this real-time modeling. We can say real-time simulation. Then, for example, we say that it's digital shadow, and it is IoT, for example, IoT-based field monitoring. And when we have this data collection, data gathering online, and closed loop or control back to the environment, then we call this all technological solution as digital twin. For example, a typical example is a smart irrigation system, which irrigates the field or environmental area based on sensor data and based on image processing data. And from my experience, as I see with the sensor data, usually, typically, or from the literature and from the solution, what I have seen, mainly this feedback loop is based on sensor data, which is soil moisture, air, soil moisture, soil temperature, air moisture, and air temperature data. What I'm working on now, and what is in my mind, how we can combine these two parameters in this digital twin, really to see by two parameters, by two parameters, I mean soil, air, and the object, but we in our case have plant, or in the agriculture is crop. And that's my main idea of what I'm thinking about. And there are from my point of view, quite a lot of challenges, or what we have to think about is this time frame, time scale, because of course, when we can provide with soil data every 5 minutes, then with the plant data, we can provide every 5 minutes, but then it takes a lot of computer power in processing this data, and it's we cannot get this feedback so fast. And of course, we have always also to think about this changes in the time about particular plant. For example, when we are talking about potatoes crop, then these changes are more quick or more fast, as for example we know from our days experience with plant which is Salix integris. So this challenge stays on this rationale between data gathering, data processing, and real this closed loop control. When we are talking about digital twins, again, from an academic perspective, from the research papers, what I mainly work on is this monitoring digital twin and predictive digital twin. But I included also here that, for example, we have also imaginary digital twins, and we have this autonomous digital twins and even recollection digital twins. For example, reconnection from the memory from the farm or from the environmental this solution, but where we have historical data. From my perspective, or what's interesting for me in this digital twin specific for ecosystem modeling is that when, and usually I use this slide for my computer science colleagues, when we are building digital twin from physical object like airplane, like some robot, we usually say, or we take it as the axioma that this object doesn't change a lot over the time. It stays the same. It doesn't grow. Probably there are some influences of environment on some parts, but it doesn't grow. It doesn't change in the shape over time. It doesn't change in the structure and in the growing speed. But contradictory, when we are talking about digital twins from the ecosystem objects, as I say, it could be agriculture or horticulture or environmental scientists, that what I'm saying to my colleagues is that this object is changing over the time. And what does it mean from computer system point of view? It means that here you can see this potato crop, for example, and potato crops has this particular growing stages. And for each growing stage, there is need to adjust measurements. When we say about sensors, the sensors of course stay in the soil, and we doesn't change their sensing frequency. But for example, with drone data or with picture gathering, then in the first part there could be a picture taken not so often, but for example in the middle season the measurements have to be taken more frequently. And of course we have to count this ratio always about how often do we take these pictures, and what we will do with these pictures in processing time, because it takes time to take them, and it takes time to process them. And this changing nature of the object, for me, it is this challenging and interesting part, especially from technological point of view. And of course, here I showed a little bit of what I found from research literature, that for physical, mainly what what this digital twin, what is the aim of this digital twin. So we take these measurements from physical environment and show in the graphics in order to really to see this dynamic of object. But of course, the big challenge is, or still interesting part is on the right side of this slide, because it's virtual model, and how the challenges or the this interesting part is how to build this model in virtual environment from the urban or rural area. And in order to, when we are talking about, for example, houses or buildings, whatever, they don't change over the time in contradictory from, for example, for this tree. And then that is very important to know this biological cycle or life cycle of the this biological object. For example, in this case, it's a tree because it grows and it changes over time. And in order to build this real digital twin, we have to know in terms of data, in terms of algorithm, in terms of equation, what is this growing speed and what is this growing cycle for that tree. Here, from computer science, in order to build this digital twin for environmental purposes or for this agriculture, these technologies what always are used, we use this sensing from for the soil and air. Then we use usually drones. We store this data in cloud storage. Then we process this data. We build 3D models, and then from 3D models, we set up some parameters, for example, for ecosystem, what we would like to gather. And then we analyze, simulate, and send back this some actions or some order for actions. For example, typical is this irrigation. And currently, but our idea with Juris also was that to simulate at the end of the day, not today, but I hope in the nearest future when we can, let's say, play or play with particular parameters from environmental solution and see what will be outcome in terms of, for example, evapotranspiration data. For example, here, when we are talking about this, I started this all my experience in 2019 when we developed. I worked in Valmiera in Vidzeme University of Applied Sciences, and we developed the Horizon project for environmental simulation. And the idea was in order to really save the initial this hypothesis from agriculture scientists came that you need to have this field capacity and saturated soil for crops, this enough water availability for crop in order to crop for grow when we don't have this precipitation. But my hypothesis and what we tried to figure out how to simulate it is that it's not so much about really field capacity, but it's about plant requirements in particular growing stage and adjusting this plant requirement for water for particular stage, for particular health condition in order to survive during drought period is, let's say, my passion, what I'm still thinking and working on. And I will show you my first potato experiment. We also did that we didn't irrigate potatoes as much as necessary according to the literature, but we did it less in order to let potatoes just survive this drought period. What's outcome? Outcome is that we actually save water, because the precipitation when we have it's very good, but our idea is just to help to plant or crop survive till next precipitation. Floris, just also remind me about time, because as you see, sometimes I can talk about my passion quite a long, but
I know, yeah, no problem.
Yeah.
I think we still have time. Yeah,
Yeah.
I already gave a winstwaarschuwing, as we call it, that you can be enthusiastic and take a bit more time. That's why I said 50 minutes, and to other people I say 25. No, I'm kidding. Go on.
So anyway, about research methodology, in order to build this digital twin, which really holds, for example, plant or environmental based solution or agricultural solution, firstly, anyway, we have to build this, as I say, first living lab. And yeah, probably I will go on to next slide. Set up living lab. We evaluate this first stage is evaluation of this crop or plant growing cycle with particular technologies, with particular sensing data. Then we have this real life object characteristics in terms of, as a computer scientist, we know how to now build appropriate this digital twin computer system, data processing system. We identify these viewpoints, see who would like to see what kind of, for example, data in the dashboard and so on. And then we can set up this outcome already in real-time setting. Here is this, I would say, this difference, or I tried to show in this slide this difference. When we are talking about agricultural crop or digital twin in agriculture, that usually I say that we have this one season advantage, or probably sometimes it's also disadvantage when we are talking, for example, about potato production. Of course, there are this horticulture field when you still have much more seasons, but here we see that we have this one season. And usually we have this data acquisition. Then after data acquisition, I'm going to conceptual modeling of digital twin. I use such methodology as 4AM. It's for enterprise methodology. I then based on this remote sensing data and already validated algorithms for object, or I say object from computer science, but it's actually crop or plant from ecosystem. I develop this growing algorithm, and then I'm also going to farm in order to have more precise requirements, and then based on that and based on our living lab experiments, we build this user application data analysis, data processing, and digital twin already in this ecosystem. Here, from the for the urban areas, I developed another workflow, I can say, but what's here included, what I did that before, this image analysis by application of artificial intelligence algorithms, and also this sensor data, and also experimental data in real mesocosms, as you see here in this picture. It's a first year trial, as I told already. Yuri is from computer science. It is that also we as computer scientists need to see how this real life object behaves, as we say, in order to know how to build this digital twin in terms of computer software and dashboards. Yeah, here you see what came out from the first year, but we developed dashboard for mesocosm evaluation in terms of evapotranspiration evaluation and calculation based on soil moisture data, soil moisture and soil temperature data. Of course, next point is to add this visualization part in terms of image processing data. Here are some pictures from my previous experience in the potato field. We started with potato experiment for automatic irrigation, which is real than digital twin according to definition. So we have also actuation in real life. And here, what we did, we measured really more than 1,000 potato seeds, if I'm correctly say that in English, or potato crop. And every potato has QR code. And before we planted, we measured each potato. Then we wrote this data in the database. When the potatoes started to grow, we fixed the time when they emerge, and then all these stages. And here you see also drone image taking process. And practically for potatoes during the growing season, active growing season, we took picture every day. We took this soil parameters in terms of moisture and temperature, soil temperature, and here you see also automatic irrigation. And here is when, and we separated, or we built this experiment from two parts. One is the irrigated part, and the other is non-irrigated part. But usually I have also a question from agriculture scientists. So what was the outcome about in terms of this harvest or field? We got a little bit difference, but we found out that still, though, that part which was not irrigated somehow survived. Even from the soil moisture data, we saw that they're supposed to be already wilted, but still they didn't. And now we also try to figure out how to also explain this phenomenon in order to use that for a more precise digital twin. Yeah, here is this digital twin for potato plants, which could also be used for environmental modeling in terms of irrigation systems. And yeah, when we are talking from data and simulation models to digital twin. When we learn what is this difference? Here you see in the right part simulation model from Wageningen University, what we took as an example. And here you can see you put some data parameters, and you see biomass distribution and other calculations from simulation. It is this digital model part. When you see already real-time sensor data and some characteristics, then it means that you have already digital shadow. When you see real-time, when you build real-time actuation, then we can talk about digital twin. Here you see backend from this simulation model for water stress detection. It's built in Stella. This is for potato plant in order to predict harvest based on soil moisture, temperature, and moisture and temperature data. And some practical applications also in the picture. Here, this in the middle part, you can see from my, as computer scientist, this model, what we call about model, for building this digital twin. For me, it's important to understand basic concepts and basic processes. Here, requirements for each process, and also the main goal for digital twin, what this digital twin is supposed to shadow and what kind of actuation we would like to have in our environment or in our digital twin. That's from my side all. From conclusion part, I would like to say that yes, it is important to think about how to show this dynamic of nature objects and how to match this various time series in order to simulate this development of object. And with various time series, and I mean that we have sensor data, for example, every 5 minutes, we have drone image data every day or every second day, and probably we have a soil analysis every month or probably once in the season. And all these parameters have to be matched in one time series in order to build this simulation model more precisely or integrated in digital twin environment. So that was all from my side. I hope not too fast. I hope some things that
no, it's a nice overview, and there's so many possibilities, and especially what you can do with it in greening cities, also drought, and so there's quite a lot of potential there. And did you have, well, maybe first, are there any questions about the presentations or the presentation, or otherwise you had some specific questions for us as well, Ginta, maybe about the possibilities, or maybe, yeah?
My question was generally, what is your experience in order to matching these time series, or your opinions for this? And second question is probably what is really valuable to put effort on digital twin direction, for example, in this actuation part, or and probably where this let's do the nature do its work, for example. Probably have some comments.
Anyone wants to respond?
Well, for me, it is a tool that as a company we would very much like to implement. We sell growing structures for trees, and it is very hard to convince people why you should use plastic structures beneath the soil in order to make a tree grow. And in practice, what we see a lot is that the realization to use one of our products comes 10 years after the decision has been made not to use our products, because they see that the tree doesn't work. And of course, we have our own experiments where we have installed a tree in a basic fashion, then one in a Stockholm mix, and then one with one of our systems, and see how the trees reacts to the soil that is there, and so that we can prove, look, the tree is growing growing this way, or the tree in our system grows faster, better, However, what you come across a lot is that, yes, but that is in the United Kingdom, and we are over here, and the weather is different, and the soil is different, and everything is different. So whatever experiment you've done, and you made your point, yeah, but that doesn't account to us. And it would be so perfect to have models, as you put in your slide 6, where you say, well, a building always stays the same, but a tree, it grows. But of course, it has to do with what happens beneath what are all the parameters that make the tree grow. Those are tools that are so interesting for us to really state that, okay, well, you are at this location. Okay, now we're going to use a model. We are going to put in the tree in a normal soil and see how it reacts in due time, in 10 years, 20 years. How does the tree develop? And then we are going to switch it to another system, and we see how that develops. And it might be that the tree is not the right one, because due to climate changes, we have to accept that some trees cannot be used anymore. In the Netherlands, for instance, we've always used oak trees everywhere. However, with the climate change, it might be that in the future we shouldn't use oak trees anymore, because then they cannot cope with the climate changes. And there, to use a model that really states that, okay, well, we can change the parameters and show what on this location the consequences are of this tree growth. I mean, that would be so helpful.
Yeah.
And of course, when it comes to data, real-time data, we work together with a couple of universities in the United Kingdom, Manchester University, Yale University, I believe, who have data of different projects, and if that can be of help, mail me and I will put you forward, because, well, we have data that could be of use in those cases.
Yeah, that's this case. Thank you for your really valuable comment. Because what I see exactly, we are working in that direction in order to show or to convince or customer or convince people for particular solution in that particular place, to take into consideration that for example, climate conditions. And here simulation can help. If you know, if you build this model, you can show long term before experiment. And and about data, it's very valuable, because anyway, this model, even what you saw in for potatoes in still environment, anyway, there is differential equation behind, and there are data behind. We need to have some data.
Yeah, for sure.
In order to build. Okay, thank you. Sure. Thank you, Farrell. Yeah.
Yeah, we'll put you both in contact. And that would be very nice to hear more about that, Harold. It might be even a topic in a climate cafe, because I think it's really complex, because Ginta is measuring, of course, the soil temperature, also the soil moist, and also how the leaves are expanding. But there's a lot more in real life. The groundwater tables, salinity, because they're potato monitoring in the Netherlands as well, but mostly because of saltwater intrusion. So
Okay.
what can you do with it? So there's so many parameters, also the quality of the soil, and you cannot measure everything. There were some climate cafes actually about the project Thirsty Cities. There are some trees being monitored as well. Some even in Amsterdam with juices. So there's basically a tree with a lot of sensors. It doesn't feel really nature-based, so to say, if you see a tree like that, but it gives immense data. And of course, it's about the data. What are we going to learn? Because, as you say as well, some processes are very slow. Given advice and then see the benefits after 10 years. I mean, we have to monitor a lot, and it would be great to gather these data and see what we can come up with, and especially how the monitoring would advise us to do things differently, or be saving water, and do we need the plastic crates in the ground indeed or not? Yeah, that is amazing. Yeah. Maybe other comments?
Well, I wanted to
Simply,
react
yeah.
on your question was basically, or what you were asking was the first thing I wrote down about data collection and the time steps, because I was actually wondering myself, like, what's the data with, of what are the datas with the time steps that causes bottlenecks in, firstly in calculations, but also in coming to conclusions, because you're gathering a lot of data, and luckily, like Flora said, we are gathering, trying to get more data all the time. But if we have data on totally different time steps, different qualities of data, then it's really hard to integrate it for you in one model. And I was thinking that even some data might be redundant or not useful to give like basic outcome of the total growth, for instance. I was wondering, are there parameters that are more important, less important? You already mentioned that growth stadia was a kind of new thing that's seems to be, and kind of logical. That's more considered more important in the model that was considered beforehand. But I was wondering about the data themselves, like pH, temperature, moist. Are there considered like did you encounter problems like we didn't get this data, or we found a bottleneck because the time step is too big for this data? Is there like one or two or three particulate kinds that you encountered?
Yeah, Yuris. You have
Yes,
question, comment.
I could probably comment on that.
All right.
Yeah.
So basically, we are gathering data at very fine resolution, which is a problem, because not in many locations well, in most locations you don't have power connection, or it's quite expensive. So I guess this is a like field in development. So like in the Riga, in a live project, we are installing very similar sensors with very similar architecture, with very similar loggers in field conditions. And actually, we've had this sensors also, such sensors also in our living labs in like real residential developments. And we are collecting data basically at 5-minute timestamp, and it's okay. I mean, for soil moisture, probably hourly timestamp is okay because it doesn't change that much. But for example, when we study hydraulics, like water level or discharge, then but a nice thing about, let's say, the platform we are using, I mean, we are using some, let's say, commercial platform for this project, is that in such platforms you can set rules. For example, if water level in a swale we are using groundwater level at the same time infiltration rate. So if the water level is increasing fast enough, then we start collecting by the timestamp of 1 second, for example, to get good infiltration rate. So sky is the limit. My main question, because I mean it's of course nice for research, and I mean this is research money that pays for these projects. But in fact, like in order to validate this leaf area algorithm that Ginta is developing, you also need to like manually count the leaves or something like that. It's like it's such a I mean, it's there's I think we are at a very early stage, and my question that bugs me. I mean, it's fine when we have a research grant, but what would be solutions that industry would pay for? So, so in the cities, I mean, it's like rain gardens. I don't think, but well, maybe if the topic is, let's say, measuring ecosystem services and for example, decreasing of urban heat island effect. I mean, trees are one obvious object, so to speak, that needs to be measured in many forms because trees are both valuable and expensive if you don't maintain them. So I guess if I mean, so in urban environment, I would say it's mainly trees, and but then of course rural it's crops. So where the money is. So it's actually I mean, maybe we can just discuss this in pure NBS Chardonnay and Flores.
Yes.
Let's say what is
Yeah.
where is the money?
Yeah. Where's the money to get the right data?
Yeah. And which essential criteria or what
Exactly.
we should
Yeah,
measure as well,
that-
of course, because
Yeah.
that relates to industry. And we did the literature review, of course, in The Perfect Sponge. And I think, of course, well, soil moist is a no-brainer, but there are a lot more to take in consideration, and every location is different. So I also agree with Harold, the future image that we could have a model and that you just do the location and then criteria would come up, what is important. Yeah, that would be an ideal picture, but a lot of more research would be needed.
Yeah, I mean, one obvious thing which I think is really promising, and I mean, it's not just in terms of, well, not just in terms of blue-green digital twins, but urban digital twins is that basically you have the network of municipality cameras, and you can get all sorts of data, including condition of greenery, including ability. So basically, you don't need to have a sensor for everything. You just need to have good cameras and good machine, let's say, image recognition, validated image recognition algorithms. That yeah. So I mean, the ideally, of course, if we could see whether the tree is watering just from the picture or from the information gathered through the municipality camera, that of course would be the dream. I think we're still quite far from it, but it's good to dream.
Yeah, indeed. So
we even use Google Street View for some tree analysis, actually.
Oh, all right, yes.
Yeah. We
It's not a
see
high
that a car
frequency,
drives by every 6 months, so that we can see after a couple of years how the tree is developing.
Yeah.
All right.
Sometimes it doesn't have to be very difficult, but
no,
that's a very innovative, I'd say. So you look where data is already, right? So
yeah, and twice a year, yeah, for a tree, yeah, it's it might be even a good frequency, and the data is
enough.
available. Yeah,
Yeah.
very practical.
Yeah.
Yeah, absolutely.
So an add-on for climate scan, Flores.
Yeah.
Tree counter. It's like an API with Google Street View.
Yeah, indeed. Yeah, for research probably we it will be nice, and yeah, and I think gathering the data will be great. Yeah. So what are the next step, Ginta? You're now counting a lot of leaves, and what prospect? So if we invite you back in half a year, would you have a ready digital twin? What do you think? And we can say,
It's more a question even from recording, you know.
Yeah.
Unofficially, I can promise a lot. But yeah, this about counting is I started with 100 potato seeds, and now I'm counting leaves just to prove if my IE algorithm works correctly, or what is let's say what is error, or what is this rate of justfulness, precision rate of my algorithm. That's why I counted also leaves, but then of course it turned out a little bit deeper. That really I found out that it is interesting in order to build really this digital twin, for example, for tree, when you can really in a digital environment set up criteria, set up growing rate for tree, and you can see in virtual environment how this tree grows in particular environment. I'm not so optimistic to promise it till next year.
Very good.
At least not visually, but probably with some yeah, I'm thinking about, and I have a lot not a lot, but at least couple of students who are also so excited about my idea. Probably something good will come out, at least one that we can present.
That's great. Yeah, and there are plans to do this experiment also, not in in Riga, of course, continuing, but also in the Netherlands and maybe Italy, and that would help, of course. Also, by different locations, do we gather the same data? Do we try to new monitoring forms that might be more cost effective? But it would be nice to see what is the right green choice in this case, and how to set up digital twin. Shall we, because it's almost time, slowly close to an ending, or any last remarks, or no? Shall we look at the next week, I would say. So next week, Frans van der Ven is coming, retired now, professor at TU Delft, and he's going to talk about the 3-point approach, 3-puntsbenadering, as we call it in the Netherlands, and it's about dimensioning climate adaptation at 3 points. One with excessive rainwater, for example, but also in a regular situation, and how to not over-dimension our living environment for different challenges. So I hope that's nice. And the coming weeks, there's also more. Maybe Sydney, Shernay, any promises you can make?
Yes, I have some of the master students that were involved with the Floating Future project that's now finished their thesis. So they're going to give us their presentations. And then we also have a speaker from South Africa, not confirmed for exactly when yet, but they are developing biochar technology to retain soil moisture and to improve the growth of vegetation in the agricultural sector, in the wine industry specifically.
Nice. Yeah. So a lot of great topics. And Harold, I still remember if you have data or a great presentation about what is happening in the UK, that will be great. So let's keep in touch on that one.
Yeah, I have to see whether or not I have something that does not come across as too much as a sales pitch.
Okay. Yeah, let's do that, because we don't do sales.
I'm
We do research.
representing the business side of things, people. So yeah.
Yeah. But it's always good to have a perspective from different angles. So yeah. The triple helix. It's private, public, and everything. So that's great. Yeah. Thanks again, Ginta. I think you showed what kind of prospects we have, and also what we can expect in, let's say, a year instead of half a year.
Okay.
So thanks again, and hopefully see you all next week.
Thank you.
All right.
Thank you very
Have a
much.
great evening.
Thank
Really
you.
great.
Bye-bye.
Bye.
Thank you. Bye.
Bye.